Hi everyone, my name is Jackson Farley and I've done a project with Jeffrey Marshall about a distributed SPI project for our real-time operating systems class. The goal of our project is to perform a task migration at process granularity over a serial peripheral interface connection or SPI connection between two launch pads that are running the same OS kernel as quickly and as minimally as possible. So our process goal and outline has a couple constraints. We only have a single file system that has access from a single launchpad, and we want to be able to send an entire process with position independent code and position independent data and different symbols that have to be linked to another launchpad and have it run successfully and be able to send back a interpreted or reasonable result that makes sense, that the master can make sense of. And we envision that this kind of computing and this kind of sending of processes could be really useful in modern Internet of Things with edge computing and other distributed operating systems. So our basic setup for the lab is the bottom we have a launchpad connected to a sensor board, and the sensor board houses our SD card, which has the file system and some LCD stuff. In this lab, we're just using the file system portion. And in the blue box, we have the slave launchpad that's going to be running our algorithm. The algorithm that we've chosen, or the process that we've chosen, is a simple skyline problem, which can be solved with the divide and conquer algorithm. The basic setup of the problem is that we have several buildings or rectangles, and we want to create one master outline of all of them by merging them together. So our basic transfer sequence is the master needs to request a symbol table from the slave launchpad. And from that, it can link the other functions like heap malloc and heap free to the slave so that they can run correctly on the slave. It then creates the code and the data from the ELF file we have on a file system. That is all sent over in a specific defined protocol to the slave, which is then able to interpret the code and data, run the entire program, and produce a result. So here I have the master on COM3 and the slave on COM4 of PuTTY, and they're going to be able to demonstrate basically how this looks. So we can see if I do a simple list all of the files commands on the master, we have a list of files, but if I do the same thing on the slave, we don't have any files, so we need to send all the information we want. I've named the program that I want to send skyline.axf. So I just type in that and it's send program. And it's looking for the symbol table. So on the slave side, I will tell it to receive program. And we get our result here printed out via the debug console of the master. And you can see that it took almost no time, but of all the things we did, we got the symbol table and we then asked for the code, we asked for the data, and then we were able to get the results once the slave signaled via a GPIO wire that it was finished with the result. And that's our demo.